Alright, let's take a look at IP subnetting part 1. So we might have a problem like you're given a 192.168.10. The whole range, right? 0 to 255. And you're asked to go ahead and create at least 4 networks. Let's go ahead and run through that process. So what I'm going to do is I'm going to draw a T-table. Like so. The left side is going to be the network. The right side is the host. I'm going to draw a couple circles. These circles represent bits. So for example, in the network section, if I see a 2 circled, it's not 2 networks, it's just simply 2 bits that are applied to the network. I plug in the formula 2 raised to the n and 2 raised to the n minus 2. I label down here nets and hosts. And yes, this mouse is overly clicky sounding today. Sorry about that. And then my favorite part, of course, is you come in next to the circles and you draw Pac-Man from the 80s. Alright, so our objective is to acquire the ranges for 4 networks. First thing I want to make clear is this 192.168.10.z. We know the subnet mask by default is 255.255.255.0. And we know the divider line goes here, where the left side is going to be the network and the right side is going to be the host. Each one of those numbers represents 8 bits, right? Because an IP address is 32 bits wide. That T-table you're looking over here is the same T-table I have over here. I've just modified it quite a bit. Okay, so let's play. I need to figure out 2 raised to what number on the network side, the left side. 2 raised to what number gives me at least 4. So what I can do is put an n here and say n would have to equal a 2. Because 2 raised to the second power is exactly 4. If I was asking for 5 networks, I would need to use 3 here, because 2 raised to the third is 8. So, on the right side here, on the hosts, notice that the host is 1 number, and that's 8 bits, so we represent an 8 over here on the host side. The only thing that changes between class B and class C is that we'll go ahead and have a 16 here for class B, because my divider line has moved 1 to the left. It's now 2 numbers that represents hosts. We know that if it's class A, I move it over out between the first and second octet. So it's 3 numbers, it's 24 bits. So that's the only thing that really changes on this diagram between class A, B, and C. I can't stand methods that teach you different ways to do it for each class. Too much work. I'm not going to do it. Okay, so what we're going to do is this, is if I had 8 bits to start with and Pac-Man 8-2, how many are left over? The answer is 6. If I plug those back in for n, 2 raised to the 6th power, 2 raised to the first is 2, double it, 4, 8, 16, 32, 64, minus 2 is 62 hosts. And back over to the left, 2 raised to the second is 4. So I met my criteria of 4 networks, and I have 62 hosts per. So we know that, but our machine doesn't yet, does it? And how our machine, whether it's our, we're talking about our PC or talking about the router itself, it knows it based on how the subnet mask changes. So we started off with a /24, right? That's 24 ones going across, 255 for 8 of them. 255 for 8 of them, 255 for 8 of them. We ate 2 bits. We stole it. So now we're looking at a /26. And if we convert that, it's like drawing 26 ones out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2. 1, 2, 3, 4, 5, 6. Because an IP address is 32 bits. You know, it's kind of like looking like this. Originally, our divider line was here. we said, I'm stealing 2 bits, so now the divider line is here. So we need to figure out the binary of 2 ones turned on. So it's going to be a 255, 255, 255 dot 192, because it's a 128 turned on plus a 64. All right, the final thing we need to figure out before we start our ranges is how wide is the range? In other words, do I have how many hosts? Is it .50 and .100? Are they in the same network? Or 150 and 220, are they in the same network? We need to figure out who's in whose network. So what we do is, there's a couple ways to do it. 3 ways I know of. Here's the way I like to do it, so of course I think it's the best. We come over here to the bits we stole, which are 2, and draw them. 1, 2. And as you know, we deal in bytes here. And you just circle the rightmost one. Well, that's a 64. That's going to represent what's called either your delimiter. Some people call it the increment. Some people call it the range. Equals 64. So that is one way to do it. Another way is, 2 raised to the, we do it over here, 2 raised to the 8th power is 256. If you minus your subnet mask, which is 192, you'll come up with 64. And the third way is take a look at your hosts, which is 62. Add 2, which is 64. 1, 2, 3. All of these check. I like the first method, and I use the other 2 to quickly check it. The reason why is sometimes I notice that students will do a 255 minus 192. Because they think, okay, 255 is the highest they can go. So they end up with the limit of 63, and that messes everything up. Or on the third method with the host, if you don't do the math right there, then your hosts plus 2 are going to be wrong. So again, the goal was to get to 64. Let's take a look at another screen and see how it applies to the ranges. So we're given a 192.168.10.z, and we determined that the delimiter was equal to 64 with a /26. The ranges are the easy part. We simply take our IP address, 192.168.10 dot and start at 0, and all we do is we keep adding the delimiter to itself. So 10.64, 10.128, 10.192, 10.256. Now bells should be going off, right? Sirens, Boulette special, whatever. Because 256 cannot be created with 8 bits. So I draw it just to say, I can't use you. You told me we'd have 4 networks. And notice here the 0 is the start of network 1, network 2, network 3, network 4. They match. They must match. So my first range starts at 0, and my next range starts at 64. It's 0 through 63, 64 through 127, 128 through 191, 192 through 255. Which means if one machine is a 192.168.10.40, and the default gateway is 192.168.10.80, it would not work. These guys are on separate networks. So we're almost done. The last thing we need to do is what I call PPM. You won't find it in a book. It's called Pete's Pogo Method. Gonna draw me. And there's my pogo stick. Jumping up in the air. Pete's Pogo Method clearly states that whenever you go up, you must come down. Well, the same thing is true with IP ranges. You can't use the 0 there. Take a look at the 192.168.10.0. That's what's called the network ID, or the subnet ID. It's what's used by the router. So we go up 1 to 1, and then we can't use 63. Because remember, when we had the full range of Class C, we had 0 to 255. and you know that you never used the 0, and you never used the 255 because it's a broadcast. Well, now instead of having that one large network, we have 4 separate networks, don't we? 4 sub-networks. So it's up 1 to 1, down 1 to 62. Up 1 to 65, down 1 to 126. Up 1 to 129, down 1 to 190, and then up 1 to 193, down 1 to 254. Those are your ranges. So again, the ranges are 1 to 62, which makes sense because we go back, you told me you would have 62 hosts. You see, the math has to work. 65 to 126, 129 to 190, 193 to 254. Now let's do some new, other tricks with Class C. Let's take it to another level. Let's say, for example, you do an IP config or show IP interface brief on a Cisco device, and you see the IP address is something like this. Let's say it's 200 dot 1 dot 2 dot 111, and the subnet mask is 255 255 255 dot 224. Now there's a couple things we can determine from that. Here's what I would do. I look at that and I say, okay, that's 8 bits. That took 8 bits. That took 8 bits, and that took 1 for 128, plus 64 is a 192, plus this 32 is 224. That took 3 bits, so I'm really looking at a /27. I advise you to learn the slash in 255 format, interchangeable. You see /27, you do a 224. You see 224, you do a /27. Now think about it. If you go back to the T table for a minute, let's think about how we got to a /27. That had to mean that our Pac-Man had to eat 3 bits, didn't it? Because a Class C address starts with a /24, and you ate 3, and that gives me a /27. So, I mean, just a lot of things we can determine here. We can go ahead and say, okay, if that's the case, then that has to be a 5. And if that's the case, that is 2 raised to the 3rd, which is 8 networks. 2 raised to the 5th is 32, minus 2 is 30 hosts. We know what the delimiter is going to be because we stole 3 bits. And that rightmost bit, the bit furthest to the right, is 32. Now, let's say the problem asks you something like this. They say, you're given 200.1.2.111. What is the network ID for that IP address? Well, we simply create our ranges. 200.1.2.0, add the delimiter, add the delimiter, add the delimiter, add the delimiter, and that's enough because we're looking at 111, which is going to fall here. So I know that 111 falls in that range, so 96 is its network ID, 97 is its first usable address, 127 is its broadcast, and 126 is the last usable for that range. So by just looking at that subnet mask, we can tell all kinds of information about it.